Module 4, the Skeletal System, Histology, and Movement. Introduction.
In the last module, you gained a good understanding of the skeletal system as a whole, looking at all the bones in the body. Well, now we're going to study more about what those bones are made of. Remember that bone is classified as connective tissue, and the job of connective tissue depends on what that tissue is made of. The matrix comprises the structure of connective tissue. It's the material that's outside the cells. So bone matrix is the material that's outside the bone cells. And that is what we will be learning about as we study the histology of bone, as well as how bones move.
We have to first take a look at the bone cells before I can talk about the bone matrix, or the extracellular material, because these are the cells that make it. Let me first introduce you to a few terms. The term blast means immature cell. The term cyte means mature cell. And the prefix osteo means bone. If you know those terms, then you will have an easy time understanding the next two definitions. An osteoblast is a bone-forming cell. It refers to a cell that makes immature material that is forming. An osteocyte is a mature bone cell surrounded by bone matrix. This word literally means mature bone cell. Well, osteoblasts are the cells that produce bone matrix. I like to think of them as the construction machines at a building site, blasting the material so that building can begin. They are part of the building team. Once the osteoblasts have produced the matrix material and it is fully formed, then the cells are completely surrounded. At this point, they are osteocytes. So, like cells in cartilage, osteocytes are mature bone cells that are encased within a space within the matrix. We call that space a lacuna. Now, there's one more type of bone cell I want to introduce at this point. It's called an osteoclast. An osteoclast is a large, multinucleated cell that breaks down bone. The term clast means to break. Multinucleated means that there is more than one nucleus in each cell. Why would we need cells that break down bone? Well, bone material doesn't last forever. It naturally begins to deteriorate on its own. So your body needs to constantly be breaking down old bone and making new bone throughout your life. Another reason you need osteoclasts is to tap into the storage of minerals within your bone. When the body needs a supply of minerals, the osteoclasts can break down some of your bone tissue so that those needed minerals become available. So we can say that bone is made up of three types of cells: bone-forming osteoblasts, mature osteocytes, and bone-dismantling osteoclasts. Now, the bone matrix is what we want to focus on because it is the matrix that gives bone its characteristics. The matrix is filled with collagen fibers, which are composed of protein. The fibers have been secreted by the osteoblasts. Collagen is an important component of bone because it provides flexibility and tensile strength. Remember that tensile strength is strength that can withstand pulling, the same way that a rope does. The rope is flexible and strong when you pull on it. Calcium salts, sometimes called calcium minerals, are also a part of the bone matrix. A salt is an ionic compound, so calcium salts contain calcium ions. This material is sometimes called a mineral because the word mineral has to do with inorganic crystalline compounds. This just means that the ionic compounds can form solid crystals in the same way that table salt has been formed. The calcium salts are primarily a mineral called hydroxyapatite. These salts are not produced by the osteoblasts, but rather are brought to the bone matrix by the blood. Most folks know that bones store calcium, and it's mostly in the form of hydroxyapatite. But notice that there is a good amount of phosphorus present too. In fact, hydroxyapatite is about 40% calcium and 20% phosphorus, which is a significant amount. That's why we need a good supply of calcium and phosphorus in our diet to build strong bones. Phosphorus is pretty easy to get in our diet if we are eating healthfully. Calcium is a bit more challenging to get for some folks, though, so that's why you often hear people encouraging us to eat more calcium-containing foods for healthy bones. You just need to be aware that phosphorus is also an important component of strong and healthy bones, too. Well, hydroxyapatite is important to give bones crystalline strength, but it also provides compressive strength. Remember how the collagen strands provide tensile strength like a rope? That's good for pulling on, but have you ever tried to push a rope? What happens? It folds up, right? Well, that's what the collagen fibers in the matrix would do if you didn't have hydroxyapatite. It provides the compressive strength, so bones can withstand the pressure of weight. Can you see how bone is wonderfully designed to provide both tensile and compressive strength. Module 4, the skeletal system, histology and movement. Experiment 4.1, calcium salts in bone. In this lab, we're going to learn more about bone tissue and its properties. Now, bone tissue is made up of calcium salts and collagen. Those two components give bone its strength for support and flexibility. If it didn't have the support, we would have bones that were very rubbery and bendable, and so we wouldn't be able to stand up. Without the flexibility, if we just had the strength, our bones would be very brittle, and so they couldn't withstand any kind of impact without breaking. So in the lab that we're going to do, we're going to remove the calcium salts from bone and see what happens to the bone tissue. So to do that, we need to have a chicken bone. And you should probably get either a wishbone or a wing bone from a chicken because those are thin enough bones that we can remove all the calcium salts from them in a shorter amount of time. And you want your bone to be a raw bone. So you need to get raw chicken and cut that bone out of the chicken material. Try to remove as much tissue as you can and then let it dry overnight. At this point, that's where this bone is right now. I want to show you the flexibility that the bone has naturally. And so you can see I'm bending it this direction. This bone is pretty, it's got some flexibility, but it's also very stiff. I can bend the bones together and you can see they've got some flexibility, but they hold their shape really well. And so we are going to remove the calcium salts from the bone by letting the bone sit in white vinegar. Now to do that, we have a jar. I have a glass jar. You want a jar that has a lid on it, and you can use any kind of jar, even a pickle jar that you've rinsed out or something. And you want to put your bone in the jar and then add white vinegar to cover the bone. And you can see that the vinegar is covering the bone right now. And so I'm going to put the lid back on. Now you want to let this sit for 7 days. In the interim, though, every day you want to take your bone out and bend it and notice the flexibility and if it's changed at all. Note that in your lab notebook as compared to the day before. And so at the end of 7 days, we'll take a look at what the bone looks like and talk about what happened. It's been 7 days since we put our chicken bone in the vinegar. And so now let's take it out and take a look at what it looks like. Hopefully you've been checking yours every day and keeping track in your notebook as to how it has changed. I've done the same, and you can see my chicken bone is extremely rubbery and pliable. And so let's talk about what's happened. Now this should have happened to your bone as well. Within for my bone, it took about 1.5 days to get to this pliability. If you used a thicker bone, then it probably took a couple more days for it to get like this. Vinegar itself is a mild acid. It's actually acetic acid. And the calcium salts in bone are a chemical called hydroxyapatite. If you look at that chemical, you'll see that it has an OH or hydroxide ion in it. That behaves as a base. So when the vinegar and the base of the hydroxyapatite combine, they react and the hydroxyapatite molecule breaks up. The calcium will dissolve. And so what's happened here is all of the calcium salts are gone out of this bone. What is left then? It still looks like the same wishbone we put in there. Well, what's left is the collagen. And so by doing this lab, we can see visually that collagen provides flexibility to our bones. The calcium salts give it a compression to be able to withstand compression. If we did this lab to where we were able to remove the collagen but leave those calcium salts in the bone, we would have very brittle bones that were able to crack easily like chalk might be. So hopefully by doing this lab, you get an understanding of the two major components of the bone matrix. The collagen provides flexibility and the calcium salts provide strength.